is predicting flow imbalances in your injection mold. So what I'm going to cover today is mostly around multi-cavity systems and the type of imbalances you can have, whether it's a geometric imbalance, whether it's a shear-related imbalance, or related to the heat transfer in your mold. So brief introduction. Flow balance is a main concern for any multi-cavity injection molding system. I'm sure all of you know that. Something important to point out is that Moldex 3D is a true 3D meshing approach to CAE. So this is in contrast to some of our competitors who are not always using true 3D mesh. And the disadvantage to like a 1D or 2.5D approach is that you're not always preserving the geometry of your part and runner system in the most accurate way. 3D mesh is guaranteeing that you're going to have the best possible geometry preservation, and this is vitally important for something as sensitive as the temperature gradients that we need to capture to predict balance properly. So it's very important to note. So as I already mentioned, some of the main causes that we're going to look at are non-uniform flow lengths. So this is pertaining to geometric balance. The shear heating effect, which you'll see there's some melt flipper examples if you guys are familiar with melt flipper, and the temperature effect or temperature distribution and how that affects the balance. So if you guys have any amount of injection molding experience, I'm sure you've seen different sorts of runner layouts, and I'm sure everyone has an opinion on which one they prefer. What's very important for any runner layout to get the best possible balance in your mold, it's important to have even flow lengths between each cavity. So, and this, I'm not talking about family molds here, but in the case of a mold where all the cavities are identical, you definitely want your runners to have equal lengths to each cavity. You can see the layout in series on the left. This kind of breaks that rule. And oftentimes it's very difficult to establish a process on a mold like that where the dimensions for all of your cavities are similar, because you have different rates of filling for the inside cavities compared to the outside, different rates of packing, different gate freeze times, all these things. And this can affect your dimensional distribution at the end.